Hello everyone. Today we are going to be going over Unit 4, Lesson 1, which is quadratic graphs and their properties. The first couple of lessons in this unit are a little bit weird because they seem to go over like the same things, but sometimes you get formulas and sometimes they're just talking about like what things are. So there are some things that I'm going to go over in this video that you may not see until Lesson 2, but just going to throw them in there anyway. So first of all, what is a quadratic function? So if you remember back in our polynomials unit, we talked about classifying different types of polynomials. So a quadratic has to do with the highest exponent. So if you remember, a binomial means that you have two terms, trinomial means that you have three terms, monomial means that you have one term, but quadratic has to do with the degree of your polynomial, and in this case, quadratic has to have a highest degree of 2. So what that means is that you need that x squared term. That is what makes it a quadratic. You might have something in front of the x squared. You might be adding some coefficient times x. You might be adding a constant. But all of these examples are examples of quadratic functions. So these first two are quadratic trinomials. This third one is a quadratic binomial. And this last one is a quadratic monomial because there's only one term. And this one is what we call the parent function because basically it gives us the simplest version of a quadratic, and everything else is just some variation of that. It's the same shape, but something about it is changed. Either it's shifted or stretched or something like that, but it is the same shape. And we call this graph a parabola. So if you are interested in what that looks like, this is our parent function, y is equal to x squared. So you'll see that it looks like a U shape, and that's our basic curve that we're working with for this whole unit. So moving on a little bit. Now this is the part that this is the formula that you don't see until lesson 2, but I threw it in there just because it's actually easier than not telling you the formula. So the axis of symmetry, if you look at this shape, you can see that it's symmetrical. So if I cut it in half along the y-axis, I can flip those sides, like if you imagine like a piece of paper, flip those sides in, and it is the same on both sides. So for this one, our axis of symmetry should be pretty easy because it's just x is equal to 0. We can cut it in half with the y-axis, which is where x is equal to 0. So for that one, that's going to be our axis of symmetry. But we also have this formula, which is x is equal to negative b over 2a, and that will give you your axis of symmetry. So we'll do just one of these since this is technically the next lesson, but I did want to show you how this works. So if we have 2x squared minus 4x plus 1, so we have our parabola right here. Now to calculate that axis of symmetry, that line that cuts through it makes it the same on both sides, we find negative b over 2a, or specifically x is equal to negative b over 2a. So I'm going to type x is equal to, now my b term is the middle term, so this is already negative 4. So it would be negative 4 divided by 2 times a, which in this case is 2. So if I type that in, it tells me that I get an axis of symmetry of x is equal to 1. And actually, just for clarification, I'm going to take away that negative there and put it on top. So the negative of minus b, because it's minus a negative 4, gives me x is equal to 1. And you can see on the graph, it already graphs it for you, and I can double check because, yep, that does seem to cut my graph in half, so I know that that's going to be my axis of symmetry. So that purple line is the axis of symmetry for this particular quadratic. All right, so next I want to talk about the vertex. So the vertex is the highest or lowest point on a parabola. So if it's the lowest point, like the one that we just showed, the vertex is the minimum. If it's the highest point on the graph, then it's the maximum. And the thing that makes it the minimum or the maximum is this first term right here. So if I make this a negative, if I make that 2 a negative, that flips it upside down. And then my 2 down here, part of my formula would change. And so it would flip upside down, and then I would have to move my formula, change that number to be a negative, and then I get my axis of symmetry. So one thing to notice is that whether it opens up or down, that axis of symmetry is always going to go through the vertex, because the vertex is the turning point of the parabola, whether it's like this and it's the minimum point, or if it's like this one where it's like an upside down U shape and it's the maximum point. The axis of symmetry is always going to go through the vertex because that's the turning point. So if you're cutting it in half, the line that cuts it in half has to be going through the turning point. So something else to keep in mind. So the way that you can calculate the vertex is you find the axis of symmetry using that formula, and then, well, you could do it two ways. First way, you figure out what x is, plug that into your original equation, and then figure out what your y value is. I guess I should have y equals here. Or, once you've got it graphed, you just click on the point and it'll tell you. So I will say that if you're using Desmos, you don't really have to go through all of the algebraic steps. At least I'm fine with you not doing that. If you have specific questions about what's allowed on tests, feel free to contact your individual teacher if it's not me. But if it's me, totally fine with you just using Desmos and clicking on the points and finding those. So for this one, our vertex was -1, +3, and really you can just use these same steps, put it into Desmos, put in your axis of symmetry, click on where you have the intersection of the two, and that's how you can find the vertex for all of them. So again, this one is going to be a minimum. If I had a positive, nope, that one was a maximum because it was upside down. This one is a minimum because it's the lowest point, and this one has a vertex of x is 1, y is -1. So that would be my vertex there, and this one would be a minimum because it's the lowest point on the graph. Hopefully that's pretty straightforward. Next question is, are there any restrictions on x? In other words, how can I find my domain, and then afterwards, what range could I have? So the types of things that limit your domain are square roots, because you can't have a negative, or you can't take the square root of a negative number. The other thing that can limit your domain is fractions, because you can't divide by 0. So those are the two things that you always have to look out for, square roots and fractions. Quadratics have neither of those things. So I could plug in whatever value I wanted to for x for any quadratic. So for the domain would be all real numbers, because I can plug in whatever I want and it's going to give me some y value. It might not be a nice y value, but I'll get something. And then the range is what kinds of values could I get for y. So you might think, well, if I can plug in anything for x, then that means that I can get anything for y. But that's not necessarily the case, because, for example, if you look at this graph, after that vertex, I don't have any y values that are less than that vertex. So the range is going to be limited by that vertex. So if the range is a minimum, then you're going to have y is greater than or equal to that minimum value. So our y value is -1. So for this one, our range is going to be greater than or equal to -1. And if I take out this, it'll shade it for me. So you can see that all of my y values show up in that shaded area. And then if it's a maximum, so I know I just keep showing you these two examples, but I think it pretty much covers the main ideas so that you understand it. So if it's a maximum, this one had a maximum value of 3. So then instead of greater than or equal to, I'm going to make y is less than or equal to 3 because that was the maximum. So if something is the maximum, then all of your other values have to be less than or equal to that. And that is how you would find your range or your possible y values. So you find the vertex, and then the domain is always going to be all real numbers for quadratics, and then your range is going to be depending on whether it's a minimum or a maximum. So hopefully that helps you a little bit. I did want to go through one more example. So this one says an acorn drops from a tree branch 20 feet above the ground. The function h is equal to negative 16t squared plus 20 gives the height h of the acorn in feet after t seconds. What is the graph of this quadratic function? At what time does the acorn hit the ground? So in my handy dandy Desmos, I'm going to type this in. Actually, let me check. I feel like at some point it did let me do t and sometimes it didn't. Plus 20. Did that work? Oh, it did work this time. Okay. So I'm going to type that in just how it is in the question. H is equal to negative 16t squared. Just as a reminder, to do the exponent, you can either use the keyboard, and then this key or this key, or on your keyboard, not that one, but like the one that you type on, if you do Shift and 6, it will type a caret, like that little guy, and then that will also make it an exponent. So once I graph this, the first question is, what is the graph of the quadratic function? Well, done. And also, this one's really, really steep, and maybe not the best way for me to look at this. So something that I can do is click on this little wrench. Now, my x's are okay, but my y-axis is like really smushed together. So I want to see less, nope, other way around. My y-axis is okay, my x values are really smushed together. So I want to stretch that out a little bit. So on my x-axis, instead of going from negative 20 to 29, like if you look at these x values, I really don't even get close to like 5. So I'm going to go from negative 5 to positive 5. All right, now I can see it a little bit better now because I can see my y values all the way up to 20, which is my maximum. That's where my vertex is. And then I can see my x values a little bit more clearly as well. So I've got my graph. I've got reasonable numbers on my axes. And the next question says, at about what time does the acorn hit the ground? Okay, so this is telling me that I have h is the height and t is the time. So when the acorn hits the ground, it's going to have a height of 0 because it's on the ground. It doesn't have it has 0 height away from the ground because it's on the ground. So on the graph, I want to look for where my height is 0. Now, for this graph, my height is basically my y value, and my t is basically my x value. So I want to look for where my y value is 0, and that's going to be on the x-axis. So when I click here, this is where my height is 0, and it says t is 1.118. Now I do not want to click on that point, although it is also where h is equal to 0, because that is where time would be equal to -1. So if time is negative, like that's not really a thing that we are interested in because we're looking for how long it takes until, we're not looking for like when it hit in the past. So this is going to be an example of a problem with a different domain and range. Ooh, I've got 30 seconds. So the domain would have to be where time is greater than or equal to 0. That would limit that. And then the height obviously can't be less than 0. But that would be our time, 1.118 seconds for that problem. So hopefully that helps. Let us know if you have any questions. I am just about out of time. So hope that helped.